Now welcome students to yet another experiment in optics. Now today we will be finding out the focal length of the convex mirror. So our aim is to find out the focal length of the given convex mirror. The ray diagram is as follows. For the lens we will be using an object needle.
Excuse me ma'am,
Yes?
then what will be the use of this lens used?
See, basically our aim is to find out the focal length of the mirror. But then, since it will not give me a real image, being convex mirror, I need an object which can converge its diverging rays. So in order to get a real image and in order to locate it on the optical bench, I need some converging instrument like a convex lens. That is why we are using it. Now an object will send out rays which will be converged by this lens, and if by your setting they fall normally on the mirror, then they will be following the path till center of curvature. Again they will be retracing their path and they will be coming back to the same point. It means if the object is here, I should be able to locate its image also above this. But still, the point which I want to locate is towards the right. For maintaining its position, again I will use a second setup. Once you determine what is the position of the mirror, you can remove it in the second case. You can see I have shown it with a dotted line because I have removed it from the previous setup. The lens remains there itself, so is the object. But now you can see there is no image here. Reason being, the rays are now actually converging to a point called C. Otherwise earlier they were not able to converge here. Now here, since they are converging, they will be giving me a real image. This is the image. To locate it, I will be using an image needle. So the radius of curvature, which is a gap between the pole of the mirror and the center of curvature, can now be easily located with the help of this image needle. So the radius of curvature will be this gap PC. Half of that will obviously be giving you the focal length of this mirror. Now let's see what all readings we need to take during this experiment. We are taking radius of curvature to be r and the focal length to be small f, the relation being this is double of the focal length. Once you have fixed the position of the lens and the object needle, you will get some position of the mirror. In the second part of the experiment, you will be locating the position of the image, and hence r will be image distance minus the mirror position. If you do half of that, you will be getting the focal length. So finally the formula becomes r is equal to pi. This is the gap between the pole of the mirror and the image, and the focal length will be half of that. It will be measured in centimeters. Can you tell me what sign will it bear?
Positive.
Okay. Even if there is some certain confusion in this, it will be itself coming out in the calculations. So now let's go on to the optical bench to realize this ray diagram. Okay, now the ray diagram which I have explained you just before can be realized on the optical bench as follows. This is the convex mirror that we will be using. Its focal length I want to determine. This is the convex lens which will be helping me out for converging. This will act like an object needle, and obviously for the first part I won't require any image needle because the image will be formed on this needle itself. So this will act as the locator for that image. Now in the first part, since I am requiring only these three, I will be adjusting this needle to get a tip over tip image. Remember, the pole of the mirror as well as the optical center should be aligned in a same line as the tip of this object needle. Now we can locate the image. Slight parallax is there, for which you have to move the screw.
And what is a parallax?
See, parallax is a kind of error that usually comes in the optics experiment. In this there is a relative shift between the tip of the object and the image that you are obtaining. If you try to move your head left and right from this optical bench, there will be a difference in speed with which the image is moving and the object needle is showing the move. Now you can come and have a look at this. It's coming tip over tip. So this is what you are expected to obtain in the first part of the diagram. Now students, you can observe that wherever we have the object, even the image is located there itself, because the rays have retraced their path from which they were coming. Now even if you try to move left and right from the current position, you won't be able to see the two tips going away from each other. There is a tip-to-tip alignment of both the object needle as well as the image. This is what you should be aiming for. Now there is no parallax in the current setup. Now, having determined the position of the mirror from the first part, we do not require this mirror for the second part of the experiment, and hence we remove it off from the optical bench. Now, this is my image needle, and I will try to locate the image over it by moving it. Remember, I don't have to move either this object needle or the lens, because they have already been set from the previous setup. Now just try to locate for the image. I am moving it. Just tell me wherever you see the tip-to-tip image. Are you? No? Are you getting it? There is no parallax? No. It means now I have received the image over this being my previous location for the mirror, and the gap between the two is telling me the radius of curvature. Do the half of it, that will give you the focal length. The half of it, as I told you, will be the focal length of the mirror that was there in this upright. Now one more thing, the result that you will be getting after doing the calculation of focal length will be coming out to be a positive one. That is, the focal length of a convex mirror is positive, because the image is always formed behind it.
And what can be the precautions in this experiment?
Well, the precautions in this experiment can be that while you are setting up the entire experiment, the tip of the object, the center or the optical center of this lens, as well as the pole of the mirror should all be in a straight line. Before doing the experiment, you should remove any kind of parallax that is there. And the level of these two rods should also be the same, which can be easily adjusted using a spirit level. So, we finally conclude this experiment having found out the focal length of this convex mirror.